Okay, I want to talk real quick about when you're given a scenario and you're trying to find an equation or an inequality that matches. Now, this really differs from situation to situation, but there's always going to be a few key things that are at least going to help you along the way. So there's three main things that we're going to need to find. Whenever you're reading your scenario, you're going to need a total, or what I'm going to refer to as the total. Okay, you're going to need a number that's being multiplied or divided, especially in our two-step equations, okay? And then we're going to need what I'm going to refer to as a constant. So I'm going to go into a little more depth on each of these here real quick. So our total is going to be what's on the other side of the equal sign. It's going to be something that equals something or something that's greater than, maybe less than a number. This is going to tell you how much they have, period. It's not being added to, it's not being subtracted to. This is, say, somebody has X amount of dollars, or all together they have, this much money. So this is kind of what you're looking for a total. This is going to be on our equal sign, and it's going to help you build your equation or your inequality because it lets you know what's by itself. Next, we have what's being multiplied or divided. Most often, you're going to see this say like something per week or something per hour or something per number. And this is going to be in your scenario what you're going to have multiple of. So, and a lot of times when we have our situations where you're buying multiple items, or I'm buying several pairs of shoes, or I'm getting 3 drinks, or something like that, that's going to be, if I have multiple of an item, that's usually what's going to be on our multiply or divide. And this is what in our equation is going to be right next to the x, right? So maybe it's 2x or 3x or 4 pairs of shoes or something like that. But that's going to show you this section of our equation. Last up, we have our constant. Our constant is what is not being messed with. This is like a one-time charge. In our situations, so let me say one-time charge right here. In our situations where, say, if you were going to go rent something and you had to pay $15 just to get it, then you paid something per hour. That $15 just to get it that one time would be our constant. Or say you're going and buying a pair of shoes and you're gonna, you're buying several pairs of shoes, but you're only getting one pair of pants that costs this much money. So it's whatever happens once, and this is always either going to be added or subtracted to our equation or inequality. Okay, so having said that, I want to look at an example. So let's look at this one. Sean has $10 to spend on fishing bait. He knows that he wants to buy 1 jar of salmon eggs for $2.69. If he wants to spend the rest of his money on night crawlers that sell for 55 cents each, which inequality could be used to help him determine the number of night crawlers that he can buy? Okay, so if I'm setting this up, I first off want to say, okay, here are my pieces. I'm going to have something times x. I'm going to have plus or minus a number, and then I have an inequality. So I'm going to have some kind of inequality, and that's going to be on my equal sign. Now I know I'll determine what that inequality is later, but I know it's not an equal sign. Okay, so I can't put an equal sign in there yet. First thing I'm looking for is what's my total. In this case, I see Sean has $10. He can't have any more than $10. He has $10. That is our total. That's going to be alone on its side of the equal sign, or its total sign, our inequality. Now, if he has $10, you have to start thinking, well, can he spend more than $10? No, he has to spend less than $10. Okay, he can spend all of that $10, so it can equal to, but everything he has to buy either has to be less than or equal to the $10. So that's how I get my inequality. Now, if I'm looking at my answers, all of them have a 10, but look, C and D are greater than. That tells me that he wants to spend more than $10, and he can't do that. Now, let's keep looking through. So we found our total. We got part of it. We were able to eliminate some answer choices. Now, we keep moving along. So we know he wants to buy 1 jar of salmon eggs for $2.69. That tells me something really important as well. The 1 jar of salmon eggs for $2.69, he's not buying a second one. He's not buying a third one. That is a one-time cost. So because of that, that is going to be what I called my constant. I'm going to be adding $2.69. So I'm going to be plus $2.69 because we're looking, all of it together needs to add up to that total of $10. Okay, so I know I'm going to be adding a positive $2.69. Now, if I'm looking at my answer choices, I can already see which one it's going to be. But I want to finish this off. Okay, last thing I'm looking for in my equation is what's being multiplied. What am I doing multiple times? Well, if I look at my night crawlers, they sell for 55 cents each. That means if I buy one, I pay 55 cents. If I buy two, I pay $1.10. If I buy three, I pay $1.65. That means I am multiplying that one. Because I'm multiplying that, there's my number that goes with my x being multiplied. So now I've been able to build my inequality here. So if I was going to write this out, I would have 50.55x plus 269 is less than or equal to 10. Now, I don't see something exactly like that, but I do see one with all these pieces. I need 269 by itself. That gets rid of b for me and only leaves me with a. Now, they switched it around on you and they put the 269 in front. Doesn't matter. The important part is that it's by itself. Okay, so hopefully this helps out a little bit with at least breaking down our sections. Again, it's not an exact science, but if you can find these three different pieces in an inequality or in an equation, it's really going to get you on the right track and help you figure out which answer choice you're looking for.